Uh, I welcome everyone on day two, session number three of Day03 sponsored workshop on hands-on introduction to LabVIEW and its applications. We have with us Dr. Giraj Nyati, uh, uh, who is currently working as a Chief Operating Officer at Genesis Power Infrastructure Limited. Dr. Giraj Nyati has done his BE in Electrical and Electronics Engineering from 1980 to 1984. He has done the MBA from Sukhadia University, Udaipur in 1988 to 1991, and he completed his PhD in Advanced Optical Recording Characteristics of SBSNIN, ESBTE, and AGIN SBTE based phase change material from IIT Bombay. He has worked in many organizations. The leading are as a general manager in Amketi, then uh, CTO and senior vice president in corporate technology, chief operating officer meters, and presently he is with Genesis Power Infrastructure Limited. He is responsible for the entire operations of the company, where Genus is a public listed company and operates in the field of high tech AMI and smart energy metering product and services. Uh, he has Dr. Giraj Nyati. He is an inventor himself, and he holds 3 US patents and 17 Indian patents. So, with these words, invite Dr. Giraj Nyati. The patent information was old, sir, of 2017. When I took your biodata, you must have added some new patents also that we know you are being innovative. So, welcome, sir. Welcome for this session.
Okay, so thank you very much, Dr. Pariksit. So kind of you for for introducing myself. Well, I will introduce again in a different way, but let me promise you one thing. I think all of you must have just finished your lunch, and the last thing I will do is to kind of put you to sleep. So I'll try to make my deliverables as interesting as possible. Fortunately, the topic is also very interesting. So I promise you that we'll have good time, but during my deliverables, at any time, if you find that it's not what you expected, that please do interrupt me. Yeah. So let's and it's again very. I mean, obviously I got to say so, but the fact is that this is something which is being spoken about almost everywhere. This is the some industry 4.0, 4.0, 4.0, the way you want to call it, is something which is some culmination of all the efforts for last 10, 20 years that IT technology and the manufacturing and the operations, kind of management, they've discovered. Okay, so see, it's a real application of many things as we will discover together. So what just few more things and then I would start. Um, I have lived through these things. So what I'm going to show you future. I'm going to show you how 10 years down the line our lives are going to be changed. And I say I really mean it. And so it's something which I'm living right now, something which I'm doing right now. But the slides that are picked up are standard slides from mostly from internet and from some papers. So we will I'll have lots of examples. I want to show you that what really this concept means and where we are heading to. Okay, so let's start. Yes,
Nyati said
yes, Parikshit.
that some participants are requesting to turn off the video in order to save the
Okay,
bandwidth. So, sorry for the
okay.
interruption.
No, that's okay. I'll just let me
Stop
just
video.
stop video. Let me just go to. I can do it physically.
Yes.
No, but that will not help. Just 1 second, yeah? I will.
Yes.
Just give me a moment. Yeah? because as I said, this
At down there is a mute button, then there is a stop video.
actually you can do it. I can't do it.
Okay,
Now it is giving me the control. You are giving me the yeah, because yeah, I think you
I'll
can do
do
that.
that. Yes, sir,
Okay,
I've
thanks,
done
Al. Very good. Thank you very much. Okay, so now I'm seeing a screen which I'll just remove it. Okay, is it
Yes,
all set now?
yes, all set, sir.
Okay, now it's not changing. The skin is not changing. So I think the controls are with you, Pariksit?
Screen is not changing. Let me just check
Yeah.
once. Once.
Uh,
Now just see, sir. Now it will change. You can change it now.
no, I can't.
I have made you a co-host.
Uh, yeah, yeah. Now it's in. Thanks a lot.
Yes,
Okay.
sir.
Yeah, it is. Thanks a lot. Okay, so I think Dr. Prashid has already introduced me. Bitsian and PhD. It's not IIT Bombay, it's IIT Delhi. Most of my career, I was very fortunate that I could join. I could complete my degree at the age of 20 and a half. So already put in more 35 years of experience. So my experience been, let you can say 50% in operation, 50% in R&D. So again, R&D is very close to my heart. Uh, Again, not a good name to talk about, but uh, Mozabar, whatever you see, or you've seen the growth of this company. This company I joined from Greenfield, and rest is history. Had opportunity to work on very, very interesting technologies, and you must have heard about a technology named LightScribe. This technology, LightScribe, is now optical media people are still using, but not to the extent we have envisaged in the beginning. But the challenge was that you could record onto optical media. It could be CDR, a DVDR, or a BDR. But on top of it, I mean, if you have to put like it's your balance sheet or your mark sheet of class, your first year or second year, then you have to scribble down. You will take a flat pen and write down. The technology that we invented, we means myself, I was a co-inventor, Mitsubishi Japan and HP US, is a light scribe technology. In this technology, you do just reverse the optical disc, put it back on the same drive, and you can, you can make graphics and the same. You remember, there is no printer. You are using the same optical media drive to write and make some nice photographs and diagrams. Just to give you cut the long story short, about 5 to 7 million discs are sold with this patent. So really proud of that invention. Well, most of the time you invent something, but you don't see it commercially successful. And then had opportunity to work with a lot of good people, a lot of good companies, IBM, HP, Nobel laureate Nakamura-san, and yeah, that's all history. Besides, I have also done a lot of things. The two things I would like to mention. One thing is that I dreamt of this academic industry and funding body kind of cooperation in India. So with cooperation from Government of India, DIT, and we started a few projects with the likes of IIT Kanpur, CMET Pune, IISc, and Indian Institute Raman, IISc Bangalore, and II, this Calcutta institution. So, and there were a few more projects in the northeast corner of this country. I was chairman at one time, chairman of 5 such committees, and we were working on 4th generation solar cell. So what is right now, you've got crystalline solar cell, you've got thin film solar cell, and it was a good pioneer work being done in India in organic, inorganic, heterogen junction solar cells. And a lot of good people like Professor Paul, Professor Amnelkar, and these are known names in this field. And so they were my committee members, and we really did good work there. So anyway, that's another. So that was very, and we really thought like US that if funding agencies can come forward, and universities plus the industry can also come along, then perhaps we can also create some new technologies and new history in this country. Well, with limited success, but still, I thought I would mention that aspect. So that's me. Okay, right now I'm working with Genius Power as Chief Operating Officer, and Dr. Parishad already introduced my company. Okay, so I think I would start my delivery now. I mean, Industry 4.0. I mean, a lot of myth, lot of concept, lot of. I mean, you would everybody would love to talk about it, and especially people who have no idea what Industry 4.0 means. I'm just joking. See, it's all about the context. In context, like just put a diagram from the net. A 6 to a 1 person, it look like a 9. So data has got validity. Most of you are, I'm sure, your engineers, your professors, and you are teaching your students, your IT students, etc. So you got data is, the way you interpret data, the way you use data is more important. So that's the message. Industry 4.0 is nothing new. It's the application of some sort of lots of technology that we will discover together in next few slides, wherein you are really able to do some great things. Now, what are those things? So what I've done, at few slides, and I need your pardon, I need your patience that some of the concepts that going to talk about may be repetitive. So, but I'm assuming that there may be some people on the call, they might not have much idea about some of the concepts that I'm talking about. So bear with me so that we can have a very useful session today. So it's all about the context. That's what I'm talking about. Now, this slide, you all know, this is the Gartner Emerging Technologies cycle. Every year they publish it. Okay, it's very, very popular among scientific community. What they talk about is that in the beginning of introduction of any new technology, there's a lot of expectation. Okay, that's been a case all along the development of scientific. Whenever the first record of research that exists today, that you can find out in books or in publication. So there's a lot of expectation, and then when you are inventing a technology, that time people are they say, okay, I will use this technology for making some product or services. So that time could be anywhere, according to Gartner, from 2 years to 10 years. That's how they plot it. Anything beyond 10 years, they don't talk about it. So right now, if you look at 2020, then you see some ingredients like AI, artificial intelligence. You all guys are, masters. Most of you are, about it. But there are a lot of versions of AI which are still in its infancy. It's being, adaptive. It's been evolving. There's a lot of new concepts that are coming up, and we will see in few slides the regions thereof. But those technologies and are so there's a lot of expectation that humans have from this technology. That eventually what happens, they plateau. They go to that kind of peak of kind of expectation. Then this sometimes hypes, that it becomes just a hype, and some of the technologies never see the ray of light. I mean, it. It is not the technical competence of a particular technology that will always make it winner. It's not. It's the viability, it's the ability of the technology to really add to the human kind of lives in terms of a good product or services that will make it winner. So some of the technologies, the expectation go down, then there is a trough of disillusionment, the slope of enlightenment. Some of technologies that survive, they actually go to in terms of making some products and services. The reason I wanted to show this graph is that if you look at the graph of Gartner 2015, that time they mentioned Industry 4.0, and they were absolutely right that this is something which will plateau, which will. I mean, it's a debatable issue. It's not. It's a ever evolving concept, as you will discover in full side. But they have mentioned in 2015 that that's something, and it's turning out to be true. Okay, so let's see. In next 2 3 slides, what do we the bigger picture of what do we mean by Industry 4.0? Is it hype? It is a blob? Is it something is overrated? Is it something is like another thread? Is it something which is good good for consultants to talk about? So let's true sense. Let's try to discover together. Dr. Parikshit, is everybody able to hear me clearly? Should I speak slowly? Is it all okay?
Uh, little bit slowly will do. That
Okay.
maybe some morning they were telling that they were requesting other expert also.
Okay, that's a good feedback. So thanks, Parikshit. I will. I think that's right. Okay, let me speak slowly. So I've shown a graph here. Now this is a mathematical presentation. It is not a graphical presentation. And you will. There's a lot of superimposition here, and I'll explain things very slowly. So Internet of Things. Now all of you know about it. This is the connection of physical objects to the internet, and that will enable the physical object to transfer, access information in all kinds of applications. So I'm not going to elaborate more on Internet of Things. You all know about it. Everybody talks about it. So it's a trillions and trillions of gigabytes of data that is being exchanged today between these physical devices and the storage. For the want of better word, let me use a cloud. Then we talk about industrial IoT. So industrial IoT, as you look at this graph, is a subset of IoT. Industrial IoT is nothing but, again, you can just term it as the application of IoT to an industrial setting. That's it. Okay. Then what is Industry 4.0? So Industry 4.0, if you look at it, I've shown a overlapping area between industrial IoT and Industry 4.0. So Industry 4.0 is basically counting a lot on the industrial IoT. Which way? So it's basically use of cyber physical system. I'll explain, don't worry, to enhance and automate the value chains in manufacturing companies. And we will also discover slowly that what are those compelling regions. Is it something totally new? Is it something evolution? Is it revolution? We'll all see in coming slides. But just try to understand that we are talking about a cyber physical system. So we are talking about the information technology, but some physical systems also. Now, these physical systems are talking through this IoT protocol among themselves, okay, all the time using a common platform. So it is not the IoT alone, which is just the exchange of information in all kinds of applications. There are physical devices that are in tandem with the industrial IoT. If I talk about Industry 4.0 alone, okay. For timing, just try to understand now what are the commonalities between the Industry 4.0 and IoT in general. So data management is one thing which is common. Then the connectivity, you see the lower presentation. So we are talking about data management. What is it that Industry 4.0 is drawing from IoT? It's drawing five things: data management, is connectivity, okay, communication, device security, and the secure cloud. So these are the five things. So in other words, Industry 4.0 invention wouldn't have been possible if we didn't have IoT. Why? Because then I would have got these five ingredients that are absolutely necessary and mandatory for the success of Industry 4.0. I hope I'm able to make myself very clear, because this is one slide which gives you a glimpse of what is it that we are talking. So mathematically, if you look at it, it is not IoT alone. It doesn't stand as an industry aspect alone. It's a conglomerate of cyber physical systems that are IT enabled, that are protocol enabled, talk talk in the same protocol in terms of IT technology, and the systems that are, then they work in tandem to get you the automation in value chain in order to make your things cheaper or to make things better. Okay, let me go to the next slide. If anybody has got any questions, please you can ask me. I think to make the talk more interesting. Okay, so again, this slide is a very simple slide. Let's understand 4.0 from a different perspective. So when you talk about 4.0, then naturally the question comes in your mind is, then what is 3.0, what is 2.0, what is 1.0? So again, dear audience, I think the important point is there is no hard and fast boundary. So it is not like, okay, guys, this is 3.0 and this is not 4.0, or this is 4.0, this is not 2.0. Okay, and I will try to explain the differences thereof, but it is not it's not hard boundary there. Okay, these terms are coined, for want of a better word, by certain industry experts and consultants to obviously drive home a point. Okay, when we talk about industry 1.0, I mean, when we talk about industry per se, I mean, you must have seen the 14th, 15th, 16th, 17th century. The revolution started in Europe, industrial revolution, we call it. And we see in 8th class or 9th class books how the thing started. So there was mechanization, there was a steam power, there was weaving loom. These were mechanized, okay, especially in the 18th and 19th century. Then this slowly from industrial 1.0, the electricity was invented. When the electricity was invented, then the concept of mass production started. Okay, and the assembly line concept and the use of electricity for the assembly line. Then that was termed as the industry 2.0. I'll again repeat. The 1.0 is when the industrial, if I can use revolution, was actually started. Basically, it was started in Europe, okay, with mechanization or kind of use of steam power, making some manual tasks automated using some alternative source of energy. Industry 2.0 was when the electricity was invented. So started making assembly lines. People started talking about mass production, use with the use of electricity. Now, Industry 2.0 plus electronics is your Industry 3.0 in a very simple and a crude language. So, the advent of electronics, okay, changed the entire landscape and manufacturing. And when I say electronics, the computers, obviously gets embedded. Okay, so that's 3.0. That's what we are living through today. Okay, let's take a practical example, which I've shown as a pyramid. Now, how does an enterprise work? Okay, so you got an enterprise at the top, and at the lower rung of this pyramid, I've shown some products. You can see a tractor there, you can see a washing machine, you can see a TV, you can see a motor and a car. Okay, these are the products that you are serving to the larger consumer base. Okay, now the enterprise consists of, I'm talking about a large enterprise, consists of work centers. Now, what are these work centers? These work centers could be factories located all across the globe. These work centers could be your distribution houses. These work centers could be your dealer network. These work centers could be your servicing centers. Okay. Now, within each work center, you got specific lines or stations. Okay. Like let's take an enterprise. Let's take one manufacturing in X country, and that manufacturing will have multiple stations or manufacturing lines. Then, how do you integrate the efforts of all these things? You've got some control devices. Control devices are possible because I said in Industry 3.0 we have got computers, fortunately. Okay, so the efforts of the enterprises are consolidated even today through some control devices. And then obviously that also includes the field service. The products that are being given to the market are also service, and through a central control or console, you can get the data which is being gathered from the market also. So okay, so now how does the thing happen? As a consumer, I go and I order for the product. Okay, so where does it go? There's the ERP, and I'm not going to use those words, but there'll be central order capturing mechanism. Every enterprise would have to its distribution network or directly through its own server. So the order is captured. Then where does it go? So as per the set rule, set hierarchy. Now in every factory, you might not be making everything. So as per the set hierarchy, this order is channelized. Like take a car. Now I'm a car manufacturer and I have got 20 models of cars. And I have got 50 different factories world across. Now car is obviously a national centric. You're not going to, unless obviously compelling regions, but it's going to be within that country itself. So let's take that particular car company has got 5 manufacturing units in a given country. So depending on the model that are manufacturing, the server will then direct that order to a particular car factory, assuming that we are not working on inventory model. We are working on kind of when the order is received, you start manufacturing. Not an incorrect assumption nowadays, okay, because there may be some customization required. So what happens? You order gets kicked in your ERP, it is directed towards the right work center. It could be a distribution center because it may be car in your inventory, or if it is a specific car that needs to manufacture, it will be direct to a factory. Okay, then there are stations. With the stations, obviously you use all the latest technology we do use today in 3.0, and you will be manufacturing it or If it's a distribution center, you'll be servicing that particular order to a particular customer. Then the entire data comes back to a central console in most of the good companies, and then obviously the same thing is then filled to the field also. Correct? So this is how at industry 3 till today, this is how we work. There is a hierarchy of tasks that are pre-assigned in 3.0. Okay. Then what is this animal 4.0? What is it that we are talking about? Friends, the 4.0 is industry 3.0 plus the true use of some of the elements of, I told you 5 things there, of the IoTs. Okay, so what is the difference? Okay, what's the difference between industry 3.0 and industry 4.0? You are doing everything, you are servicing your customer. But please remember, industry 3.0 is a set hierarchy. Industry 4.0, all these devices, what are these elements? Let me use it. Enterprise, work centers, stations, control consoles, field service stations, these are all interconnected through a common protocol. Let me use this word right now. We can further refine it as we go along. So they are all talking to each other through a common protocol. Okay, they're all connected. Okay, so let me just go to the application part first. Now, what happens? The order gets kicked in. Now, that order is going to some storage space, but that is not hierarchical. This could go to all elements of the entire supply chain, as I mentioned here. Let me simplify my statement. So the order gets kicked in, it will automatically get directed to, with a very intelligent logic, to the centers, which of course is capable of fulfilling that order. Now there could be 2 or 3 centers. Now centers again I define, it could be factory or it could be distribution. Okay, so to make it things very simple for you, a distribution, okay, if I have ordered in, let's say I'm in Jaipur, so that order will that first gets kicking to a Jaipur distributor, okay, which is just to drive home a point, okay. If it needs to be manufactured, okay, then what it will do, that it will automatically, because these things are all talking to each other through a very optimized logic and a very complex algorithm, it will even go to all your sub suppliers, and they, to the extent they need that information, so they can gear up to produce that specific item as per your requirement. It will go to a specific factory that needs to produce that. It will go to a specific distribution channel that needs to service that customer. Okay, now you may ask, why do you want to making things so common? Why do you want to do it? Okay, stay with me for time being. I'll come back to this point again. But just to understand this slide better, please just see that what we are talking about here is that a world of interconnected physical devices. We said it's a cyber and plus the physical devices. These physical devices are enabled, not, and that's the big challenge in Industry 4.0. These devices are enabled, they can talk to each other through a common protocol. The advantage, etc. Why do we do it? I'll explain in coming slides. I hope so far things are clear to you. Just try to, Dr. Parikshit, it doesn't move again. It's stuck. Kindly allow me to change.
You are, I think, co-host, sir. Has not changed anything. Just
Uh-huh. Just do it again, maybe.
I'll again assign
I
that.
can't do anything. Why? It's frozen. No button works.
Now I have made you host,
Yeah. Thank you. Okay.
but
Okay.
can you see, sir? Downside, there is a video that
No, no,
record option is there.
no, it doesn't come. My skin is frozen. That's it. I can't do anything. Now it is moving. Besides this, I
Uh,
can do nothing.
uh,
Yeah. Okay, let's stay with that. Don't worry. Whatever you do is plan to remember it. So next time it freezes, you do the same thing again. I think that way we can save some time.
yes, sir.
Okay. So again,
Yeah.
this slide also is further elaboration of I just explained earlier. But let me go through this slide also. So the first industrial revolution we are talking about. So on the bottom side, you can see the time frame. So we are talking about 17th, 18th century. So this is the introduction of mechanical production facilities with the help of water and steam power. So that's how the industrial revolution, you remember, I mean, some of you in Europe actually started. So that's the kind of now we can always say as Indians, if you look at our holy books, then we have got that mechanization during the time of Ramayana and Mahabharata also. Yeah, you remember the Pushpak Viman that Lord Rama used during obviously that Ravana used first, and then when he was killed, it was actually came back to uh, through, and it was given back to its owner Kuber. But that this we are not talking about those things right now. But the first industrial revolution we are talking about the mechanized devices that were basically drawing power from the water and the steam. Okay. The second industrial revolution is kind of, I mean, when in the, I think the 19th century, I've given one example, not a good example of a slaughterhouse, but they were basically when the electricity was just invented and they started automizing things using the motorized power. Third revolution is what I just explained in my earlier slide, wherein we are today. That's what we are doing today, which is the use of electronics and IT in the manufacturing sector with lots of automation. So it's not like, and the fourth industrial revolution I explained you is basically the cyber physical system, which is, as I said, are talking to each other and they don't follow hierarchy, wherein it's a communication lateral, vertical, horizontal, whichever direction, and the benefit being, I'll explain in coming slide. Okay, but as you go along from the first industrial revolution to second to third to fourth, obviously, friends, the complexity, the degree of complexity multiplies. A raft of activities that happen, but these activities then multiply. Now, the naturally question that I said, let me answer you the question first. You must be thinking that, okay, fine, forget about first and second revolution. We all understand. But what is the difference between the third and the fourth? And more important, what is the need for the fourth? Okay, so let's just look at some two slides, which I'll just give you. Now, if you remember in 70s, okay, I think the car industry and obviously Japan was just coming up after the World War II, but owning a car that time, and most of we weren't born that time, were kind of a luxury. And the cars were always Americans were obviously leading the pack, and it was like a absolutely customized. James Bond movies of our times. You are younger guys, so but those cars were absolutely customized. It's a what did Japanese do? What did they do? They changed the entire landscape by a new concept, which is bringing standardization to the car industry. So I've seen when this is Rover SD1, quite a complex model, but absolutely customized. You kind of, and when I say customized, it's not on the color, etc. It's even the mechanism. There were a lot of customization that were happening. Whereas Japanese thought of this innovative scheme, they started making these cars in, in tens of thousands or millions, okay, with lots of customers. Even the accessories were standard. In 70s and in 60s, 70s, if you bought a car, obviously the cars were so expensive at that time, even the accessories were customized. So you order accessories from the factory itself. Similar thing happens to TVs, radios, and cassette players. So in 70s and subsequent years, the concept moved from the single piece flow to a mass production. Okay, so what was the advantage? The advantage was to reap the benefits of mass production and to lower the cost. Okay, so this is how things happen. I just Dr. Parishit, you got to help me out again.
Uh, Again, it is happening.
Yeah. I just can't do anything. Whatever button I press, nothing happens.
Uh, Actually, now I have to take your role. You have to assign me as a host, actually, since
Uh,
I
I have
on the
to.
On the
My
right
old
side, on
keyboard
the
is
right
frozen. It's frozen.
key,
Just
keyboard
one
has
second.
been frozen.
Yeah, that's the problem. Otherwise, I can get out and come back again. That's the problem. Nothing works. Yeah, now it's working. I don't know what you are doing, but please kindly continue doing what you are doing. Okay. So in 1971, uh, so let's understand what did Japanese do? What did they? Because it's very important for Industry 3.0 discussion. This discussion will not be complete unless we talk about what the miracles Japanese did to get them to where they are today, or they had been a couple of years ago. Okay, so arrival of lean manufacturing. Okay, Japanese manufacturing, Toyota school of thought, Toyota production system, zero inventories, just in time, JIT, okay, SMED, all these concepts were discovered by these people. What was the objective? The objective was to move away from this what is known as a single piece flow or a customization to a mass production. Understanding the cost of inventory, what it is, what it was hiding. These were the kind of concepts that were all put in Industry 3.0, engaging the workforce in product and process improvement. This was one of the major factors of success of Japanese. Earlier, even today, I mean, Indians, obviously, India has also made a lot of strides, but product and process improvements were thought to be done by engineers. The concept Japanese put across the table was no, guys, the guys who are making the product, they have the best knowledge. So involve them in decision making, working with suppliers. This was also a new concept, kind of improving their quality, tier one, tier two. I'm not going to talk about the thing. I can keep on talking about those things. Aiming for quality, parts per million, zero defects. I mean, and if you look at even in the Jack Welch era, the G, unfortunately, he's no more now. But the guy who could just change G, and you may remember, he was the guy who was the father of the thought process in USA. He used to say that either you are number one or number two, you exit. Yeah. So if you know him, it is a then obviously there was this very interesting story about. Let me tell you a joke. So a cart with two bullocks got stuck in a mud. Maybe you already know it. It's not something which I invented. I also heard from somebody. So this cart with two bullocks is stuck in a mud. So there are two solutions now. One is a engineering solution, and one is a managerial solution. Now, what is the managerial solution? So you flog the bullock. Okay, you can understand the hint. You flog the bullock. Guys, move. You hit them hard, and they'll start moving. So that's how you you don't nowadays you don't use this technique with your workforce. It doesn't work. But I'm just joking. Then there's the engineering solution. What is the engineering solution? The engineering solution is that you got those wheels are there. So you oil them, okay, and you make them more movable, so that the bullocks can pull the cart out of the mud. Heard about this joke? Now comes the Jack Welch solution. Jack Welch was the guy who turned G. He says, if I were there, what I would do, I would let the bullocks go, okay, and sell off the cart. I hope you can understand the joke. So I will let my manpower go. I'll kick them out and sell off my asset. Okay, so that's. But the reason I'm citing that example is that from there, the industry 3.3 draws a lot from Jack Welch, draws a lot from Japanese school of thought, which talks about right things, talks about kind of lean manufacturing, kind of zero inventories, kind of with customer centric approach. Okay, understood. Now, then what is the need of 4.0? If 3.0 talks about latest management concept, talks about kind of things that worked well for a company like G, then why do we need something beyond 3.0? So friends, now if you look at it nowadays, everything is moving as per the requirement of customers. Customer is your king. So from a single piece flow, from the car example I had shown to a mass production, the desire of humankind was to have a product which they can afford, the masses can afford. Let there be standardization, let there be mass production, let there be zero inventory. So you reduce your cost of by going for mass production. by making zero inventory, making millions of those cars, work with your supplier, make sure that you don't have defects in the car, and but get me a product which is something I can afford. And this is what led to the funnel the growth of Industry 3.0. But the buck doesn't stop there. The customer choices, the customer expectation are ever changing. Now, what do we expect today? If you talk about the discerning customer, we are in a age where everybody has got a mobile. Even the people downtrodden, people on the street are having those kind of accesses. Okay, 20 years ago, getting a telephone in Udaipur was havoc. I mean, some of my friends would agree. Or Jaipur was something which was almost like a, you got to bribe people and you have to wait for 5 months, 6 months. Nowadays, so what is changing? The customer expectation, the customers, kind of their way of looking at products, their way of looking at it is completely changing. So from single piece flow to mass production, now people want that I want a service, I want something which is absolutely customized. Okay? As per the need and requirement of a customer. But then what? I want it at the cost of mass production. You see the dilemma? The customers are demanding that I want something which is as per my requirement. Okay? As customized to the extent I need those services. I need those, the Ola, the Ubers of the world, the hotel model, kind of look at all kinds of new thing, amazings of the world. How did they come in existence? This is because of look at the Facebook, look at the kind of videos they make for you. You as a commoner, can you ever imagine 5 years, 10 years ago that you will have a video? Somebody has done it remotely for you based on your 5 6 months of kind of photography or whatever it is, and you are there. Can you imagine you got this WhatsApp where you are able to share information. You are equally important. You are able to talk to the world. You got these Twitters. You got everything. Where do they come from? They come from the desire of fulfilling human desire of getting that exclusivity, getting that importance, getting that thing. But the challenge is, I will not go back to 70s, 80s and pay you. Where I was having single piece flow, I was getting those advantage, maybe not with kind of products that I have, but at a very high cost. I want that importance. I want that customer inference or specific thing, but at very low. And that's where, friends, Industry 4.0 jumps in. Let me go to the few next slides and then things will become slightly more. So, what are the enabling technologies? Okay, I'll come back to that point again, that the Industry 4.0, how is it changing the entire landscape of the way the humankind is thinking, But let me just explain you what are the why is it possible, why we are talking about Industry 4.0 today. It is possible because of major innovations in digital technology, and that's what this workshop is all about. We are talking about a particular technique right now, but guys, it's a some combination, and friends, it's a some combination of many technologies, enabling technology that have been invented in the last 10 20 years, that is making Industry 4.0 possible. Now, let me go through, explain you. Advanced robotics, artificial intelligence, all these terms, sophisticated sensors, the cyber physical world. I said cyber physical world. Let me take you a very simple example. In Industry 4.0, even industry, let's not talk about a connected world right now, but how does a modern warehouse work? You must have seen some stories. I have lived through that. I've seen that. I've worked with those technologies. A warehouse, which is like, I mean, for want of a better word, I mean, kind of companies, it's like 1 kilometer, half a kilometer, single warehouse with absolutely no manpower inside, with all kinds of robotics, kind of. So, what do you got a console? You got a console. It has got, you know, you guys, advanced logic, machine learning, all kinds of technology built in. You kick in the part number that you need, and that's it. It will go out, go to that location, the robot will go pick up that part. AGVs, advanced, kind of this kind of guided vehicles that will bring, and the part will come on your desktop. Okay, this is 3.0. 4.0 is one step ahead in the modern, in a warehouse. And I'm not talking of science fi story. We'll talk about that also. Believe me, There are sensors at every location. The particular part will tell you the whole story. So those sensors are, it's counting the number automatically, and they're all interconnected, they're all talking. So they're counting the part or they're weighing the part. So if my inventory level goes below certain level, I am not doing any accounting. That particular location will automatically send through internet protocol a message that, or it will not only send a message, it will go to a particular protocol and generate a purchase order. The purchase order will also be automated based on the algorithm that you put in. You got 3 supplier, 4 supplier, you'll do a worldwide search. That's why I say there's no hierarchy in Industry 4.0. Sky is the limit. It will look at your best supplier, it will look at, and it is all dynamic because tons and tons of data. Let me not use the wrong word. The trillion bytes or terabytes and terabytes of data is being captured. Okay, and that data is being analyzed using some of these technologies: cloud computing, IoTs, data capture analytics, digital fabrication. I talk about 3D printing in detail, software as a SAS they call it, software as a service, and the enabling devices like a smartphone or if you talk about a virtual reality glasses, etc. And then you talk about an autonomous car. Today it's a it's a Google car. There's no driver. Now, how is it possible? Because it is flooded with so many sensors, and they're all talking the same language. They're all interconnected, and they're talking, and they're all this data is being captured somewhere, and this data is then being in cloud computing with so much of computing power. It's so much of advancement. It's being analyzed, and the algorithms are being developed and they're being advanced. There's nothing static here. Now, one thing which I've not spoken about so far is, guys, and my friends who are you know on the call. When I use this guy is not the right word. Okay, friends, one technology that is knocking at the door will change the way things are happening today. You have about 5G. We are still debating on 4G. In India, we have got 3G, we got 2G most of the time, and 4G. Obviously, Geo is there, 4G is there. Everybody is there with 4G, but there's a fallback on 2G because in nook and corner of this country, this technology is defunct. It will become obsolete very soon. 5G is knocking at the door. 5G will change the landscape of this world totally different. How some of you may be knowing, the only challenge in 5G is that the investment that has gone into so far in, you see those big towers hanging around in your city, yeah, huge towers with those round dishes, everything will go. Okay, 5G, unfortunately, will need a small tower every 100 meters. So, see the future. 10 years down the line, it's happening. I'm not saying a science fi story. In most modern Chinese cities, they've got this beautifully decorated tower, single tower. Okay? Tower is not like the big, which is hanging on the big city. Just a pole, like an electric pole, not bigger than electric pole. Beautifully decorated. It has got the 5G technology. It has got an intelligent sensor. It has got video. It has got all kinds of technology, which it has got a solar power thing. So you can even encompass, when you talk about a smart city, everything is encompassed in a single pole. And let me not use a tower, it's a pole. 5G, the
Sir, where it is implemented, sir?
It's there
China.
in China, in most in Yuchin it is there, in Shanghai some of the areas, and and it's just wonderful. So they do a beautiful decoration, and and Korea has also done a lot here. It will happen in India also. Believe me, 10 years down the line, our lives are going to be entirely different because 5G will change what Industry 4.0. The amount of data that is generated is mind-boggling. But there are millions of sensors that are talking to each other and flooding your clouds with so much of data. And data analytics will then work. Obviously, then I'm not touching that subject, but then new algorithms will be discovered. So this 5G is going to change the entire landscape of this world. And you've seen the news that download maybe a 3 gigabyte or a movie will be in few seconds. Today it takes hours and hours. I'm not talking about it. But these are the kind of applications that are user centric. You're understanding? So 4.0 is not it is not evolution. It is a revolution. From industry 1.0 to 2.0, 2.0 to 2.3.0, you can still call it a revolution because kind of computer speed, everything was there. But from 3.0 to 4.0 is real revolution. Okay, because it's something just mind-boggling. Okay, and that is what is it's a so what in this slide what I've tried to show are these different elements which have gone into making Industry 4.0 a reality today. Okay, so these are some conglomerate of all these technologies put together. 3D printing, you all know about it. So for rapid prototyping, for mass production, it's expensive right now. But I mean, I was reading a novel about 10 years ago. Somebody has said there was no 3D printing that time, but they're going to build factories, kind of, and they were talking about bacterial growth, kind of it was just kind of the author was not a science student. He just, thought broad and loud. But today it's a reality. You can grow. You can grow a plant. I mean, you should be able to grow a plant. And plant, I said, is a manufacturing plant. Okay, using so 3D printing is making it possible to make a smaller run. You can really create that component without making a mold out of it. And all these things are. And I'll give you another example. But in the interest of time, let me go ahead. I'll come back to some of the very nice examples which will, kind of. When I was talking about 5G and the amount of data in the industry 4.0, I'll just tell you the kind of application. When I say that this discerning customer, one application, about this, the charging station, 5 years down the line, in city, in Jaipur, everywhere, you will find these EV vehicles. I'm talking about, let's forget about car for time being. The scooties, the small scooties with the EV charging. Okay, the one very good startup. Think of it. Think of the power of the human imagination. Now, one startup company they thought of a novel concept. Look, what they've done, they envision that the cycle is a reality already in Jaipur also. I don't know whether you're in Udaipur. There, they've got you can put your it just doesn't cost you anything. You must have an ID card or something, and you can pay 1 rupee, 5 rupees, and you take a cycle, come back, and then you can put it back there. In China, it is there all every corner, nook and corner of the country. It's all e-bikes they call it. Yeah, but
Sir, even it's in Mysore also, sir.
yeah, correct. I think that's a startup. Yeah,
Yes,
absolutely.
sir.
You're right.
Means it is a government control, sir.
Yeah, but it will soon be in private hands, don't worry. So the example I am giving is just mind-boggling. So this scooty, it has got a battery. Now, you've got a charging station. What is a charging station? They've got a bank of batteries which are being charged automatically. Now, the convenience is everything. Customization convenience. Look at the beauty of this 5G technology and the power of machine learning and power of algorithm and everything put together. What it does, that station, that vehicle has got obviously chip, it's connected. Everything is connected. Okay. The charge level of that battery is being transmitted, like you're transmitting a mobile signal today, is being transmitted to the service station. So if you're out of the service station, there's a next service station. Now that service station knows that within my area, I have got, let's say, example, 500 vehicles, and the charge is varying from 20% to 90%. There's nobody who's monitoring. Now, what it does, because charging also costs money. What I said, I want to give the service to my customers, but not at the mass production cost, but at the my cost of not at the cost of my customization, at the cost of mass production. So I know in my area there are 500 scooties that are moving around with a charge of, let's say, 30 to 80%. I'm just giving some 30 to 100%, doesn't matter. So the algorithm automatically intelligently calculates that 60 to 90%, 100%, nobody will come back because the charge is sufficient. Maybe they'll move out to another area. But anything below 60 to, let's say, 40, maybe any number you pick up, there's a very high possibility that that particular vehicle will come to me, because there's a navigation which is very easy for charging. What is the point? The point is that the charging also costs money. So depending on the density, the fast or slow charging is controlled. I'll repeat. So I know that I have the probability of 30 vehicles in my vicinity that will come, that may come to. So it's just very easy. It 5 minutes, not 5 minutes, it's 1 minute job. It's just there's a battery. You show your credit card, pick up the new battery, just plug it in, put the old battery back. Okay, and there's a sensor downward, so you can't cheat. Okay, so that's it, and off you go. So it is calculating the charge, and then with a very intelligent logic, showing that okay, 30 workers. So what I will do, I'll only keep 30 battery with fast charge. charging itself is a money for me. I'm just give one example. Can you imagine the amount of data that you need for doing so? So it's just enormous. It's like mind-boggling, and this is going to change the entire landscape of the world. So let me go to this. I try to explain you, but I can, for the interest of time, I can. So Industry 4.0 interoperability, okay, in kind of which is I already explained you the information transparency, the decentralized decision, because this is something. It is not hierarchical at all, and obviously the technical assistance is whole idea is to make this technology which affordable to people in terms of products and services which may not exist today, which will be invented tomorrow. I mean, this kind of if you are able to get a vehicle, imagine where you don't need petrol, you don't need anything, and it is so well connected. It's like a mobile phone. Why would you own a vehicle? You will go, just change that battery, off you go. In 1 minute, you are out. Maybe it will last for 100 kilometers till you go to next station, and so on and so forth. Okay. So let me again, what is it changing from today's factory concept to Industry 4.0? So if I talk about again, look at the parameters. So everything is there in 3.0: automation technology, SPS, sensors, actuate, MES, manufacturing execution system, and ERP. But it's hierarchical, as I explained to you. So components, you use sensors. Attributes is a precision. Smart sensor and fault detection, you do it today. Machine, okay, producibility, performance, condition-based monitoring. These are all exist today in Industry 3.0. What is going to change in 4.0? 4.0, friends, and it is not science fi. It's happening today. The machine will tell you how good am I today. Let me give you two examples. You go to Apple. Apple, well, it's a very good quality, but still it's a product. Your phone got bad, and some of you might have got experience. So you can go to in other countries within warranty. Obviously, you throw phone, you get a new phone. But outside warranty, outside countries, people, well, after 1 or 2 years, they will get a new phone. But in India, obviously, I mean, we pay so much of money, it's hard-earned money. So we will go back to a service center. But that guy just puts as a cable, and entire history comes back. You can look at the high-end cars. Your car you bought from X city does not matter. Okay, the entire data is sitting somewhere. So whichever service station you go, they have the complete history of your data. This is Industry 3.0. In Industry 4.0, the car would automatically gone will be the days when after 6 months, after first service, second service, third service, nothing doing. The car would tell you when does it need service. It has so many today. 60% of cars is anyway electronics. Now it will go to 90%. Okay, and it will let you know that when do I need a change. The battery will let you know when I need to be changed. Okay, so it's a self-aware, self-predict, and these technologies are working today. We are employing self-predictive maintenance today in our factory, where using some not all across. Let me be very honest with you. It's not like hanky dory everywhere. But on some of the machines, we could identify those critical quality parameters. We could put some sensors. Let me stick to the car example. So your car engine oil, there'll be a sensor which is managing your viscosity. Okay, whatever is the quality parameter. Let's not go too deep into technology, but the parameters on the basis of which you decide that I need replacement of my engine oil. Those sensors are there. They're talking to cars. They're talking to similar cars of the vicinity. They're also talking to service center. Okay, so that car would let you know, guys, it's time that I need to be taken to service center. One example I had given you. This is true for your air conditioner. It is true for any other product that you're going to work with. And so it's the whole gamut, the whole concept of manufacturing is going to a radical changes with this kind of concept. Hope I'm able to clarify things. So this will be basically locally controlled modules without hierarchy. So every service station, because they're talking to each other, let me go to next step. I want to spend few moments here. Try to understand this slide. This will make things very clear to you. Okay, this is how does the entire value chain work. So let's start from the left side. So you got a product. Just for the want of it, I just made a car there. Okay, so the order will be placed. Fine. Now, as I said, you will place order maybe 5 years, 10 years down the line with customization. About the Dell and Compaq story. Maybe I can just tell you in 2 minutes. So I don't know about the composition of people who are listening to me, but 20 years ago, Compaq, IBM, these guys were reigning giants in personal computers. Okay, and laptops were just coming on. So I mean, what is compact? Okay, standard XT, AT, whatever it is, standard configuration, hard disk, maybe one or two more variation allowed. Up you go. So you place the order, compact model 101, 102, 103. That's it. You want it. This is delivery time. You get it. Nothing doing. Okay, there's no other customization possible. Comes Dell. What did Dell do? Okay, what they did was, guys, nothing doing. So they developed the supply chain. They developed the supply chain in a way where all hard disk, the motherboard of 3, 4, 5, 6 different types, the RAM capacity. So all pre-tested, all cabinets, etc. So they got these massive inventories in a central warehouse, and they've got these beautiful assembly lines, which is doing nothing but just, so you got an internet, okay, pull out the form, tick, 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 tick. I want this CPU, this RAM, tick, 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 this hard disk, close, this is payment, order goes to the warehouse, okay. Within 4 hours, the computer is assembled, tested for next 4 hours, and after 8 hours, there's a very fast mode of movement. They also tied up with a logistic company. Within 24 hours, the computer is at your desktop. What happened? The compact was completely destroyed. The company. So what I'm saying is that, look at it, a company like a Dell, $1 billion company kind of a thing, serving you a computer of your choice at your doorstep within 24 hours. Okay, so this is something, the beginning of so-called this industrial revolution. You see, that's why I call it as a revolution. It's not devolution. So let's go back to this slide. So you got this. In industry 3.0, it's all decided. Okay, but here, so you will have batch size. Okay, which is, for want of it, let's that all the ingredients are, the customer is completely kept informed of. Okay, if there are some specific parts that need to be manufactured, there's a 3D printing there, next generation robots, intelligent power tools. It's all about the assembly lines. Then what happens? You got a product which comes out, delivered to you. Now look at it, the entire data, even the product, is stored in cloud. Okay, complete history. One of the finest things that we are also doing in Genius is the traceability. Now, after 5 years, I mean, this is something not new for very standard good companies. You bring a product to a good company, just by scanning, they will tell you the complete history about that product. What was the raw material? Who was the operator? Which factory it was manufactured to? So all this data is there. Then there's a product usage data. Now imagine a situation: a particular car model is, all these cars are talking to each other also through that protocol. On smart meter. Government of India has got a 250 million meters are to be replaced with smart meters in next 3 to 5 years. You will all know about it. Okay, so 3 to 5 years is the time when we are going to replace 225 crore, 25 crore meters. Now, what is the beauty of a smart meter? This product will tell you how good am I. If there's any problem with the meter, it will tell the utility, guys, I'm bad, stop it, I'm running fast, I'm running slow. Okay, and in our country we don't have a differential tariff. You understand differential tariff? We have different, sorry, I'm wrong. In the industrial sector, like in the night time, from 10 o'clock in the night till 6 o'clock in the morning, when the power rate is different. Okay, in Western countries, this is the culture. So what they do is, the product I'm talking about, smart meter, they've got multiple channels. So you connect your washing machine, okay, the products that you don't need to run, and the services that you don't need to run during the daytime. So you connect that to the differential channel, and all these things is on your mobile. So your bill comes on your mobile. You can control your particular channel with a switch. You can switch on. You know about modern cars, where when you are in India, well, we don't do it. Maybe very high-end car you will do it. but you can switch on your air conditioning by sitting in your room. Okay, suppose you want to go somewhere, it's very hot outside. You can switch on your air conditioning for 5 minutes, it will switch on, and then you can go and take your car out. Okay, so this smart meter will tell you how good am I, how bad am I. Okay, and this is going to be true with any other product also. So with the click of a button, I can switch on and switch off my my devices. Okay, and then I can make use of my electric. I can have the best optimized electricity bill. मुझे कपड़े धोने, if I have to wash my clothes, why do I need to run a machine at 10 o'clock in the morning? I'll always program it there. I put the clothes and say, okay, 11 o'clock when I do it, morning I'll get the clothes. Okay, in the bargain, if I say 100, 200 bucks, what's the harm? These are the kind of things that are going to be radically different when we are talking about industrial open or location. About 10, 15 more minutes. So let me just a few. So anyway, this is a complete, this supply, this industrial 4.0 requires a comprehensive digitization of the horizontal vertical web. I mean, it's a radically different. So you need to digitize all your processes. And that is the biggest challenge. When we talk about challenge of implementing 4.0, the biggest challenge is all your analog processes will have to be digitized, because that's the language this technology understands. Okay, so this is what this slide is basically trying to tell you. So your horizontal deployment is in your with your suppliers to your customers, and the vertical is what you have in your company, the trade, sales to planning to manufacturing to services. All these protocols will have to be digitized. This is a big challenge because today, this is a worldwide standard. India may be even poorer than that. So horizontal value chain, what is a horizontal value chain? Is this one, okay? Which is your, from your supplier to your customer, and a vertical value chain is from your sales to your internal in your organization. So horizontal, if you look at it, you are from 24%. You need to go to in 5 years. You will go to about 86%. This is happening, okay? And from today, it's a vertical value chain. It's only 20% digitalization. You will need to go to about 80%. So these are the challenges of Industry 4.0. Yeah. So these processes, and I've seen the efforts that are required prior to investment also, which is not important for this, but this is something which is happening today. So that's why every company that you talk about, any good organization you talks about digitization. Okay. Now, I'm talking about some of the ingredients of the Industry 4.0, artificial intelligence. The entire technology. I mean, when I said trillions of bytes of data that's being captured, it's being analyzed. It's being analyzed, and it's being, and then you are basically trying to kind of with some logic, which is always evolving, trying to, kind of impart intelligence to the machine. So you got sensors that are pumping tons of data, and then you got this IoT technology. It's a successful marriage of that is what is realized in terms of this Industry 4.0 revolution. Now, I mean, just to give you one more example, I mean, I've shown the ingredients. You all know artificial intelligence, cybernetics, problem solving, deep learning, machine learning, robotics, neural networks, and AI is obviously, as you know, I mean, I'm sure, Parikshit, in your department also, there has to be, and when you're talking triple IT, there'll be a lot of interest and a lot of, a lot of work is going on. Smart maintenance, rise of quality 4.0, talking about zero defect product, human robot collaboration. All these things are, being realized today. One example, when you're talking about how things are going to be, how the world is going to be different in next 10 years. You know about Touchwood in India, we got our parents and God's sake, hope that every son or daughter would serve their parents. But in Western world, that's culture, nothing wrong, nothing great. Normally when you attain certain age, then you are put in a old house or old remand house or somewhere. Now, look at the kind of technology that's being deployed today. One of the big challenges they have is that they don't have people there. So how do you serve these old people? So they've got this automated room in hospitals where even the medicine, they've got sensors. So you pick up that, and that's all intelligently connect. So you pick up that medicine, okay, and it will automatically, as I said, cyber physics. That signal will go to the doctor and to your son or daughter, whosoever you want it. Yeah, he has taken the medicine. Okay. Similarly, there are thermal sensors inside the room. So you can locate, you can actually see the position of your dear ones. Hopefully, I don't pray for anybody, but that's the level which is being done today. So it's a imagine the amount of data that's being generated. There are sensors with the medicine box, and I'm not about science fi. This is something which is being practiced, which is happening today. Okay, so so that market needs the customer customization, the customer expectation and newer applications are being discovered using this revolutionary technology, which is knocking at our door. Now, smart factory, as I said, it's a industry. If I look at from a industrial production, the smart factory will be much more intelligent, flexible. I've seen plants. We have also got a couple of lines which are 4.0. Basically, if I in a layman's language, I want to explain you what is 4.0. 4.0 is meeting the needs of your customer with kind of products and services at the cheapest possible cost. Okay, so there's a dichotomy. You have hell of customization, uh, meeting the expectation of customer and the lowest cost, and that's where this concept comes into picture. I have seen factories. We have also done this industry 4.0 in one of the factories in Haridwar, where these are fully integrated smart meter lines. What is unique? Unique is that all the components of the line, in a typical electronic manufacturing, you got a very high class card, electronic card, you mount components using very high class robotics. Okay, then you do some, kind of software, firmware. Okay, you have got plastics, you got, kind of then final customization, and off you go. Okay, so all these different elements we have bought on the same IoT platform. So so I got, let's say just for an example, we are making a PCB, we are assembling a PCB. Now that robot, that assembly robot is a very fine component. You can't see with your eyes 02, 01, very, very finer component that you employ nowadays. If you look at your modern TV, it's a massive TV of 104 inch. But if you open it, the card size may be 4 inch by 4 inch. It's a small card. Yeah, because it's possible because of miniaturization. You all know about it. So those components, that machine has got one protocol. There's an optical inspection, another protocol. There's one machine which is doing wave sorting, another protocol. We have brought them to the same platform. Now every day, even the machine maker will advertise that it's Industry 4.0 compliant. Means it can speak that language. So all of them were brought to the same platform. What is the advantage? I got a single software where I can control all the elements of that line. Otherwise, these are different vendors. One is made in America, one is made in Germany, one is made in US, one is made in India. How do you make them talk to each other? So that's where you integrate all these protocols and then generate tons of data. Then you use a very intelligent logic to draw some conclusion out of data, which is not obvious. Okay, so manufacturing processes will be organized differently with the entire production chain from supplier to logistics to life cycle management of product. It's completely gone. It's closely connected across corporate boundaries. Yeah. So all these steps actually are seamlessly connected. So smart factory, as I said, includes the entire factory production planning, product development, logistics. What is the idea? The idea being to save the last penny to serve your customer with a customized product at the least cost. Okay, so that's my last slide. I'll take then questions for 10 minutes. This is just, I just put Industry 4.0, just summarizing there. So, in nutshell, it's a consumer-oriented concept for the use of digitalized and network products and devices. If you want to understand in that way, so you got supplier logistics seamlessly through a cloud application and everything sensor. And what are those divided? You know about virtual reality. It's changing the landscape. Virtual reality is one of the classic examples of how the future look like. Today, a doctor, you give a virtual reality glass. So all the 3D MI report, MI or MR report, the doctor can see virtual reality, and when he's operating, that's there. It's there. You can see it. So he'll do a much better job. Similarly, look at the medical education. With virtual reality, you don't need to have a physical patient or dead patient to do any postmortem. You can do virtually whatever you want it. The e-learning. These all concepts are emerging from. This is how the future looks like. I said okay. So digital production is all this. I said a lot of data that's being generated, stored for maintenance, etc. And then obviously customized products and the kind of smart products which are talking to each other. So I'll stop here. Thank you. And if any question, I'll be very happy to answer. Hello, Dr. Parikshit. Hello. 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 Hope you are connected.
Actually, you are audible, sir, but I don't know about the others.
Okay. At least some of you could hear. Then I reasons to believe the others could also listen to me.
Yes, sir, you were audible.
Okay. So any question, anything, Prakshit, I'll very happy to take.
Yes, sir, I want to ask something. Sir,
Yeah, yeah. Please state your name and so that I can.
So my name is Iresha Maheshwari.
Yes, yes, sir.
So, so in the latest, there was a record by a London university where they created a high speed data that was 170 terabytes per second. That was the record made by, sir. Was that a part of upcoming industries like the future upcoming industry?
So, Irisa, I think, see what I'm saying that in order to fuel those developments, I said I showed you five elements which are common to here. Yeah. So connectivity and communication, these are extremely important. The reason I give the 5G example is because what do I do with data if I can't transfer them fast? So yeah, you are right. Actually, there is one report which has come from New Zealand, Australia, where they've even beaten that report. I'm not very sure, but a lot of technologies are being spoken about. But there is from 4G to 5G itself, there's a fundamental the data speed will be fundamentally different. Now, what are those enabling technology? There will be a lot of people will be working. So one, you got a protocol which is there's a private proprietary protocols also. You understand. With the interest of time, I can't explain those things right now. But 4G, 5G are like a general technology which are available across the globe. The 4.0 or any such revolution, they ride on public platform. They ride on common platform where everybody across the globe can speak the same language. Some of the technologies that people are developing may be proprietary for military application. So you are right that maybe if that helps, but it has to come at a cost which people can afford.
Thank you, sir.
Any other question, Dr. Parishit? You could take on and you can ask maybe if I'm not audible enough.
Hello.
Yeah, if anybody has got question, Parishit.
Any questions? Session was very informative, sir, and we have learned what is the idea behind 4.0, what are the expectation, what is the evolution. So we have seen all those aspects. On the right side, there is a participant tab on the downside, sir. There a
Yeah,
triple IT quota may be there in the list of participants
yeah, yeah.
as a co-host. So there will be three dots against that name on the rightmost. So there I have to be made the host.
Okay. I see quota cost. I got a
Host.
mute and 1 second. Let me try. Okay, just 1 second. I should be able to.
Otherwise, I can do from here. Reclaim
Yeah, you
host
do it.
role.
I think it's again for the unfortunate.
Yes, I
Yeah,
have taken
would you be able
over.
to do it?
Yes.
No, no, I would like to thank everybody for bearing with me. It's a afternoon is not always right time, but thank you for your patience learning. I really
Yes, sir.
appreciate.
But we thank you so much, sir, for you know that we are doing this session on even the weekdays in order to save our week time. And we thank you, sir, that you agreed and consented to our request. Also, you are very kind and supportive to Triple IT Quota. Sir has given a lot of expert lectures in. We have another technical forum that is called Triple IT Kernel, and Sir gave inaugural lecture for that. So,
Thank you, thank you.
uh,
Thank you then. So nice of.
thank,
Thank you, Dr. Parikshit. Thank you, everybody.
Thank you
Thank you,
so
sir.
much,
It
sir.
was fully energetic and informative as well. Thank you, sir.
Thanks a lot.
Naveen is
Really,
from
sir, you are full of energy, sir. Your voice has that energy. Thank you, sir.
I
Naveen
love.
is from Karnataka, sir. That he has joined from Karnataka.
Thank you very much.
Sir, I was just going through your website. There is a small suggestion. Can I suggest you, sir?
Why not, please?
Below, I just saw a tab stating that wear mask all the time, but when we are alone, actually, it is not preferred, sir. Means there are some scientific reasons. I think you can
Yeah.
change it to
Okay.
wear the mask when you go into groups or something like that. Just
That's so kind of you.
suggestions.
I'll definitely talk to my. I promise I have no role in that, but I'll talk to my communication guys and take them to task. You are right. Absolutely right.
And also, I visited your YouTube channel, sir. Your advertisement with Chennai Express team. It is nice. It was nice.
Okay. Thank you. Thank you. No, it's okay. I appreciate that.
Thank you, sir.
He has done the 5.0 task actually.
Yes, sir. Means my ears are active and listening, but I gave
Yes,
some
yes,
work to my eyes also.
yes, yes. Thank you, Naveen. That was just making me light. uh, Thank
Just
you,
a
sir.
friendly suggestion, sir. Thank you, sir.
Yes, sir. Thank you, sir. Thank you so much for your session, sir.
It's a
Thank you,
pleasure,
all the
Dakshit. Thank you.
participants. Thank you.
Thank you, sir. Can we leave, sir?
Thank
Means for today.
Yes, yes, kindly. Yes,
Yes, sir.
thank you.
Means are there any opportunities for engineers from this company side, sir? Means just a query.